All right, so very quickly, do I need you? Yes, I do. I'll read through there. So is everybody cool with how to calculate Q1, Q2, P38? If I ask you P38, do we have a question on how to do that? No. So if I did the calculations and I got these, what are these known as also?
Quarters.
Okay, these are quartiles. Well, what's these 5 numbers that summarize the data also known as? The 5-number summary. Yeah, I like it. Math people were very creative. You know, there's 5 numbers that summarize it down. It's called a 5-number summary. All right, I get more enjoyment out of that joke than you do. It's fun. It's always for me only. If you laugh, it's just great for you. So let's say I did some work and I got 7, 12, 13, 21, and 42. So I did the work. I got those numbers. Is that cool? And the work for these is nice. How would I plot? How would I make a box plot out of that? Well, what's the very first thing I should do to start to create a box plot out of it?
Create your scale.
Scale is so stupid important. All right. I don't love the word stupid as an adjective, but so what do you think? I'm going to start at what? Maybe. Let's start at 5. Let's make it nice. 5, and I want to get to like 45, right? So the scale doesn't have to match the data points. It just has to have a place for all the data points to go. So maybe 5, 10, 15, 20, 25, 30, 35, 40, 45. Yay. All right. Are we good so far? And now you just put lines. Instead of a dot like you're plotting it, you put lines above those points. So 7 is about right there. 12 is about right there. 13 is about right there. 21 is right there. 42 is right there. What do you box? What's the box part of it? The middle 3. I like it because that's going to contain what percent of the data? 50%. So this is the middle 50% here. And then there's your whiskers. Cool.
So each whisker on either side of it is going to have 25% of the data each.
Yeah, exactly. So what percentage is in here? There must be 25% of the data in there. Does that make sense? Because what was this line again? This line was the Q3. So how much data is below it? 75%, right? Q3 is the third quarter. So 75%. So how much must be above it? 25%. I like it. So the whiskers have 25% in them. And the box in the middle has 50% of it, of the data. So you get all the data all together. All right, maybe. And it's just nice to make really quick, if I had another set of data, same scale, but it looked like this instead, then I can ask, all kinds of questions like which one seems to be, which one would you say the average would be higher probably? Right, the average is nothing up here, but which one do you think the average would be higher probably? The second one. All the data points look like they're bigger, right? Do you guys see? And which one has more variation? First one has more spread to it, right? So this is a very quick, it wouldn't take long to calculate these, and it's not long to graph it, and it actually tells you a lot of information. And so you can compare 2 different samples very quickly. Okay, maybe. That's why they exist. I'm trying to explain that. All right, cool. Is that good?
Yeah, I think what threw me off is that they compared a couple different samples, and so they had all the boxes like.
Oh, they had them already created.
Right, and then that kind of threw me off because I think your example was just like with one box.
Gotcha.
So.
Yeah.
Now.
I think I did put a couple, but I only did one real quick.
Okay.
Yeah. But yeah, that's how you would compare them.
Okay.
Cool.
What does it mean when they only have the whiskers and not a box?
That means the data is not like the data could all be 2, 2, 2, 2, and 4, 4, 4, 4. So there's repeats. It's like the max is Q3, is the median, and the min is Q1, right? So there's not. So it's like you draw the same line twice.
Okay.
Does that make sense?
Yeah.
So there's a lot of repetition in the data, right? Or it could be like this extreme. It could be 2, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. 4. So like the low would be 2, and then all of these would be 4. So you have a line, and then you have a line at 4, and then you connect them. Cool. You were asking that last time, I think. Yeah. So that's weird, but that means your data is kind of weird. It repeats itself a lot. So it's like you draw the same line on top of itself. I like it. Because you're right, that happens in one of the problems. All right, anything else from homework stuff? Okay, so like I said, I want to show you something real quick. Though something kind of nifty. Again, I'm not excessively into politics, but I do like to keep up with it. Did I already ask you guys how many of you guys keep up with politics at all? Anybody keep up with politics? Any of you guys keep up with it like too much? No. So obviously, what's happening right now? Does anybody know what's happening? Yeah, in the Iowa caucus, and now we got New Hampshire coming up, right? And supposedly, I love that Iowa, which is so representative of the entire United States, sort of gets to set the tone for everything. It's kind of like, okay, sure. But anyway, so let me show you if this will cooperate with me. Hey, look at that. All right. So this is, I don't even know where I got, that's coming up here later. Anyway, this is one poll that was done ahead of the New Hampshire primary. So can you guys see what this means? What are they doing here? What does that mean? What is this like right here? What is this 40 and 54? What does that mean? What do you think it means? 40% of Democrats say that they are going to vote for Clinton or put their support behind Clinton. 54% say Bernie Sanders, right? So they break it down by party, they break it down by income, they break it down by age. Hillary's got the 65 and older crowd locked. This is just New Hampshire, by the way, right? This is just New Hampshire and the people that are going to participate in the primary in New Hampshire. You guys kind of with me? So what I want to show you, though, real quick, later in this class, and we talked about this a little bit, if you look at the very, very top of this, here we go, University of Massachusetts Lowell, blah, blah, Center for Public Opinion, that sounds great. Very, very beginning, they tell you some good stuff. They tell you how many people they talked to. They tell you who the people were, right? If they don't tell you these things in anything reporting statistics, then you cannot trust them. You can't, right? Did you talk to 5 people or 500? That makes a difference. But look, what's this here? This line. Deviation. No, not really, but it's related to it. So it's the plus or minus. It's the give or take. And that's what I love about stats. Stats gives you a feel for what it looks like it's going to happen. But you always have this in the background. All the percentages they reported for, I don't know what the hell this RV and LV shit is. Dem livers, I don't know. Dem loves and rep loves. But that's the so if they said 40 for this, then it could be 45 or 35, right? Which is actually kind of a big range if you think about it. You kind of with me? So that's always reported, and that's why people don't like stats. They say, well, it should give me an answer. I'm like, that's freaking life. This is the most honest math. That's why I love stats. It's very honest. It says, it looks like it's this, but it could be off by a little bit. So we're going to later this, how do they get it so precise? We'll actually learn the formula that we use to calculate that number later this class. Not today, later in the semester. All right. And the other thing I want to show you real quick is related to some part of the first homework assignment. All right, we'll just read that. Okay. So this is interesting. This is back from 2010. This is totally true. This is the numbers are completely true. If there's more cell phone masts, more cell phone poles, whatever you want to call them, then there will be more babies born, right? But does that mean, and this is that causality thing that should show up in your homework at some point, causality. Does this mean that cell phone tower radiation somehow causes women to give birth to more babies? right? Or do they, or what, or does it make men just more virile? I don't know. Right? You guys kind of with me? Or what the hell's really going on here? Why is that like duh? Why is that like duh? Come on. Why do you think that would be true? Is there a third variable that might explain both of those? Why would there be more cell phone towers somewhere? That's the word, tower. There's more, and if there's a higher population, what are you going to have more of? More births. More people to make more people, right? Sounds like a weird stance. It's much more people to make more people. But that they actually, back in 2010, I think it was 2010, somebody put this out there. Just put it out there to see if some news something or would pick up. And sure enough, a few websites saw it, posted it like it was real, and went with it. And they were like, does this mean that the radiation is blah, blah, blah? And you guys kind of with me here? So there is a connection. There is a connection between a lot of things. There's a whole website devoted to spurious correlations. These completely unfounded, the number of sandwich shops versus how many motorcycle fatalities there were in the, oh my God, don't build so many sandwich shops. But it's just coincidental. It's just random. Statistics guarantees that random things are going to happen. Random coincidences are going to happen. They have to happen. The probability that it won't happen is so damn small that they are going to happen somewhere. All right, anyway, sorry. Yes?
Well, medically, if you think about it that way, like radiation can, for like in the aspect of men, it decreases sperm production.
So by any sense, they're looking into radiation if it decreases fertility. So this, or decreases male fertility, whatever. So this goes against that in a way, right? But that's because this is really explained by population, period, right? Okay, all right. So that's causality. You see a connection between two things. That kind of, one goes up, so does the other one. But does that mean they cause, one causes the other? So like, here's a dumb example. I go watch a lot of basketball games. I'm like, so playing basketball makes you taller. That's right. Right, so that's kind of like a reverse. I think that the wrong thing affects. Of course, what actually affects it? If you're tall, there's a higher chance you're going to play some basketball. I love basketball, but I remember I met my father when I was like 15, and I was already an inch taller. And I'm like, well, that's it for me. There goes my basketball dreams. Spud Webb always gave me hope, if you know Spud Webb. 5'3", could dunk. Anyway. All right, enough of that. Okay. So, let's get into, and you missed all that, it's okay. Let's get into standard deviation and what the heck that could possibly mean. So I got a handout that's got like a worked out example, and then I'm going to make you guys do something with some data exactly like what I have on that example. But let me first start off with talking just about what the idea is. So let me ask you this. Do you guys know about the website Rate My Professors, right?
Yeah.
And I remember when I was on the East Coast, when somebody told us about it, the next day, so many of my colleagues had gone in and rated themselves. I'm like, oh my God, come on. He's amazing, Chili Pepper. Like, what? Do you know there's another website that actually tells you the grade distributions of teachers? Oh, interesting. Because it's public domain knowledge, but you have to pay. And I hate the fact that it's out there, because I understand as a student you want to get the A, but I always, because when you look at reviews, do they ever talk about who taught best? No, most of the time they talk about what did they let you do? Did they let you get like homework? Did they let you make corrections? What did they do for you to make your grade higher? Not did they teach you well, mostly. Right? Anyway, I'll let it go. But there is a website that tells you the grade distribution. So I'm going to let you guys find it yourself, and then you can pay if you want to. Let's say you wanted to take a certain course, and there were two teachers that taught that course, and they both have an average of a C that they give students. Are you with me? And everything else is the same. There's nothing really that makes you want to take one or the other. But you knew the first teacher gave B's to D's, right? And as you go through, if you go further along in college, you'll hit these kind of teachers. They don't fail anybody, but you have to be God to get an A in their class. Right? If I sound bitter, it's because I got a B, I got the highest grade, and it was a B. Sorry. So, you understand? So an average of a C, but they give from B to D. And then the second teacher gives an average of a C, but they give A's down to S. They give the full range, right? So which teacher would you take depends on your situation. Let's say you know you're going to kick ass in that class. You know you're going to kick its ass. Which teacher would you take? The one that gives actual A's, right? I didn't have a choice. It was just one person talking. And let's say and this is in university, so do you understand in university D's are passing? I know here they're not. But once you get to university, D's are good enough. Go out there and build some bridges, D- boys. Sorry. So if you know that it's going to be a really rough course, you know it's just going to kick your ass, and it's not really integral to your major and all that kind of stuff, who are you going to take? The one that doesn't fail anybody, of course, right? I don't blame you. I can't blame you. You guys kind of with me. So information about the middle of the data is very important, but it is nowhere near enough. So what we want to do is, I want to have the least amount of information I have to tell somebody that packs the biggest informational punch. So if I tell somebody what the center is, but I also tell them how spread out the data is, those two numbers are a lot of information. Are you guys with me? So I think I already, no, we haven't had it. This is our first quiz. What I always tell students, like this morning I gave back a quiz to my Math 90 class. They had an average of an 80, but this number, the standard deviation was 13. All right, so what the hell does that mean? That means the average distance from the middle grade, from the 80, to any student's grade was 13. Do you guys understand? And why does that make sense? So think about it. If I want to describe the spread of data, one kind of way to do it would be, how far does the data get away from the middle? If the data doesn't get very far away from the middle, then is it very spread out? No. But if the data does get very far away from the middle, then it is very spread out. How are we doing so far? You got a rough idea. So that's the concept behind standard deviation. That's why we want to find it, so that I can summarize data very quickly. I don't have to show everybody my 1,000 data points. I just give you two numbers and you have an idea. So, let's work with some data. Some made-up data, the best kind. Let's say I have these three data sets. What you got, Jim? Is that what you wanted? Yeah, that'll work. Oh, I'm sorry, make this like this. Sorry. Do this. If you're writing these down, do that. All right. Yes, sir.
This is 2.5, right?
This is actually, let me make sure I remember right. 2.7, if I remember correctly. Yeah, this is 2.7. So I might be doing things. No, I basically covered most of 2.5. So what I want to do, I want to get this out there, so it's not like the day before the review day, so that we're all freaking out. I want to give you time to really absorb today's lecture. On Tuesday, we're going to firm up anything else in the earlier sections. You still with me? And then next Thursday, what do you think next Thursday? When's our next test? When's our first test?
The following Monday.
The following Tuesday. You with me? So next Thursday will be review day. We won't do any new stuff. We'll just review for the test.
Do we have a quiz on chapter 2 on Tuesday?
Yes, we actually do. But yeah, I might as well put that up here since you said it. So on Tuesday, I'll have a quiz. Basically section 2, 1 through, what was it? So stem and leaf plots, histograms, and box plots, which would be, yeah. All right, 2.1 through 2.4.
You're not going to go over the information that you
We did sort of. 2.5 was where'd it go? 2.4 is box plots. 2.5 was the mean and the median. And there's a couple other little things to do. But that was enough to get into 2, 7. 2, 6. Where'd 2, 6 go? Is there a 2, 6? That's a good question. There it is. Oh yeah. 2, 6 goes right along with 2, 5. I think of those as one section. Yes? Tuesday, whatever day Tuesday is. What day is Tuesday? Okay. I like it. How are we doing so far? All right. Okay. All right. So, all right, coming back to this. Let me ask you this. Which one of these is the least spread out? We'll start easy. First one. Which one of these would you say is the most spread out?
3, 2.
So what do you think spread should mean? Which one has data points that aren't grouped near the middle the most? I mean, that's this one, right? This one's got 1 and it's got 5, but this one, see, it's not very spread out in the middle. They're all 3s. So this one's more spread out than that one is. All right, let me make sure. So you can't always on site, especially when there's a lot of data points, but a little tiny sample, we can see what to expect. The number I calculate for spread should be highest for this data set, right? And the number I calculate for spread for this one should probably be, how much spread is there?
0.
None, so it should probably be 0. Okay, how we doing? What's the average of all these? Or let me use the more technical term, mean. When they say mean, they really mean what we think of as average. What's the mean of each of these?
3.
Yeah. So and let me make sure you guys. So a sample mean, we've seen that he uses this notation here, right? Population mean, it's a population, so we want to make it look more formal. So we use Greek letters for population. So the population mean is mu. It's like a French cow sound. Right? Mu. And it's a U with an extra leg on it, right? So it's a U that's survived the fallout. Okay, how are we doing so far? We all right? So let's treat these as very small populations. Because there's a difference between the formula for the spread of a population and the formula for the spread of a sample. So let me start with population. So can my population be this small? Of course it could. Okay, I like it. So what is the mean of the first group? 3, that's crazy. And of course the mean for the second group. And do you guys see why? All I did was I took 2 away from that one and I put it on that one. So the mean's got to come out the same because they're going to add to be the same number. I like it. So the mean here is 3 and the mean here is 3. That's crazy. All right, so everybody with me so far? No. Oh, sorry.
Is it because you take the middle number?
No. Hell no. No. How do you calculate the mean? You add them all up and divide by 5, right? If the mean of 5 data points is 3, what are they going to add to be? 15, because what do you divide by 5 to get 3? You divide 15. So as long as you keep the sum 15, the average is going to have to be 3, isn't it? So if I take 2 away from that and add 2 to that, it's the same sum. If I take 1 away from that and put it on there, it's the same sum. That's why they all have the same mean. But, in general, don't guess. Just calculate it. You know how to calculate the average. How are we doing so far? Okay, so the centers are all the same. So the center by itself is not a good enough piece of information for me to distinguish between sets of data. Well, we do have something we've used that kind of tells me something about the spread. I don't know if you guys remember. We used it to figure out class width. It was the high minus the low, so it's the range, right? What's the range for this first one?
0.
All right, that looks like a good candidate so far. You're all like, well, why do we have to create something new, Jeff? We already got the freaking range. What's the range of the second group?
4.
There you go. That looks good. We said it was bigger, more spread out. But what was supposed to be the most spread out set of data? This one, right? But what's the range for this data?
4.
Shit. All right. Too bad for you guys. The range is not good enough to distinguish between them. Do you guys see that? The range is too basic. It doesn't take into account the middle numbers and how they're changing, so the range is not good enough to use. How we doing? Okay, maybe. All right, some of you guys look like you're having trouble staying awake. You'll be all right. Energy drink. All right. So let's. This is going to come out to be 0. So we can verify that after I show you how to do this. Let's look at this set of data. It's a little more interesting than that set of data. So what do you think I should do first? What am I trying to get? I think we all agreed that a good way to look at the spread of the data is the average distance from the mean. So on average, how far does a data point get away from the mean? If that's a big number, then it's very spread out. If it's a small number, it's not. So that sounds like a really good goal. I'll let you absorb that. So what do I want to find the average of? What did I just say? How far the what is on average? How far the data point is from the mean. I like it. So probably a good first thing to do, let me list my data like this, is to calculate what the distance is between each data point and the mean. So in symbols, that would look like this. Is that cool? And that's not quite right, but how do you find out how far apart two things are? You take the difference, don't you? All right, so we'll see something not quite good with this in a minute. So what do I get here? It'd be 1 minus 3, right? Negative 2, and then 3 minus 3 is 0. Because these are all 0 away from the mean, because they are the freaking mean. And this guy, of course, would be 2. Now, if I average these, though, what am I going to get? What's the sum? 0. In fact, I'm always going to get 0 when I do this, because the mean is in the middle of the data according to their value. So the stuff above the mean and stuff below the mean will always add to be 0. Holy shit. So that's like, thanks, Jeff. Thanks. That seems really good. Jeff, what the hell, man? So some of you guys might realize the key word there was distance. And I'm going to try to get you to remember what in math gives us distance, and then we're immediately going to not use it. So what in math gives us distance?
Rate over time. Excellent.
I like that. But we're not dealing with a car moving around. What operation? What function?
Ratio. Absolute value.
Absolute value, right? Why is the absolute value always positive? Because it gives you the distance. The absolute value of 4 is 4. Absolute value of negative 4 is 4, because both 4 and negative 4 are 4 away from 0. Do you guys know that? Did you ever have a math teacher tell you absolute value is based on distance? That explains every damn thing about absolute value. The reason I don't want to use it here is because what does an absolute value look like if you graph it? I know this is the most algebra you might see in here. It looks like a V, right? It's not squared, so it's not curvy. The only stuff that's curvy have powers that aren't 1. The absolute value of x has a power of 1, so it's not going to be curvy, but it can't go negative, so it just has to do this sharp. You don't want to be in this airplane, bam, because you're all dead. You can't handle it. But it looks like a V. You remember that? That's no good. That's sharp kink. Math don't like that. So what's another way to make things come out positive? What else can I do to something to force it to be positive? Especially because they're real numbers. Squared. So if I square these, because what's the problem? I really want you guys with me. Do you have to understand everything I say today? No, you just have to use the formula I end up with. But I'm crazy. I try to show you where formulas come from. If I calculate the distance, I can then try to average that distance. And that's exactly what we said sounded good, the average distance from the mean. That should be the spread. But if I use these numbers, it's always going to come out to be 0. So I got to somehow remove the negatives so they don't become 0, make it a true distance. So if I do square them right now, that's good. Makes them all positive, but what do I have to do at the end? Take the square root. Does that make sense? All right, good. I'm kind of leading you down a road that's already been chosen, but I want every step of the way to make sense because you weren't there when it happened, right? Way back when. Okay, it actually wasn't that long ago. Statistics is like the youngest branch of math, the youngest big branch of math, let me say it like that. So here I want to do this. I want to square them. So I get 4, 0, 0, 4. All right. Maybe. So since I want to find the average distance from the middle, I first calculate the distances, so then I can try to average them. We hit our first roadblock because they freaking made 0 all the time. Shit. So we squared them so that wouldn't happen. So how do I get the average of those now? How do I get the average of anything? Add them up, divide by how many there are, right? So here comes our first real formula in statistics. This is the first real one. So instead of saying add all up, add we use the symbol, the Greek letter S, because it's like sum them up for sum. The Greek letter S, who knows what the Greek letter S is? Sigma. I like it. So if you've done any stuff with sequences and series and stuff, you've seen that sigma notation. So add them all up. So add, this is that symbol. There's your sigma symbol. That's capital sigma. In a few minutes, we're going to see lowercase sigma. Stay with me now. So what I want to do, I want to add up what? I want to add these up, and what are these? They're these, right? That's like the label of what those are. So I want to add these up and divide it by, in this case, 5. How many are there? 5. I like it. So in general, it would be the letter N, because N represents the size of the sample, the number of things in your sample.